For Engineering 259, this is my student project for the quarter. I did a machining Noga arm base. Obviously here you can see the finished assembly. I'll get that cursor out of the way. So what is a Noga arm? A Noga arm is something that machinists use, like myself, to inspect parts as well as set up machines. There's not a picture of the complete assembly, the actual overall tool. This is just the base. But this base has an arm that attaches to it that you can usually attach some kind of dial indicator, whether like a test one or a normal one. And then we can use that. We can take that off of like a reference surface and then see if there's any abnormalities in a surface or if the surface is the correct height. We can also use it to set up machines to make sure that Z offsets in the machine and work offsets in the machine are set properly. My purpose was to recreate the base of the arm to kind of better understand how they work and what goes into them. And here are the parts that are included. Obviously you can see the base. It's a large cast metal base with some of the bottom milled out. The faceplate, which goes on the front. The dial that allows you to change the polarity of the magnet on the inside, which unfortunately I was not able to model here. And the stud on the top, which the base of the arm attaches to. It kind of acts as a ball joint. So the sketch, obviously on the left, you can see a picture of a official picture of a Noga base. And I found these diagrams and then kind of extrapolated the size and the features from personal use and pictures like that I found online. And here on the right we can see my hand sketch of it. Here is the base part. Obviously you can see the MDB and the datums and the mass properties. And we can go into the actual sketches themselves. You can see all the geometry and stuff on the left. And you can see on the right here we have the hole and then the threaded hole on the top. Then for the faceplate here we can see the MDB as well as the mass properties. And here on the right, excuse me, we have the faceplate sketches. Here we have the dial. This is made out of a plastic, and obviously we can see once again the mass and everything. Then here we have the sketches for that. I had a fun time doing the splines for the handle, trying to make it look nice and ergonomic and comfortable. And then here's the stud with its thread on the bottom, as well as this kind of interesting shape that I got to do by cutting with a hexagon over that, so you can make like a nut with a ball on the end of it. And obviously have the mass and the MDB for that as well. And here's the stud sketches. This was probably the most fun part to make, trying to kind of get that ball to come out looking nice and then getting that nut to look proper as well. Here's the finished assembly with everything mated together and the final mass of everything. And then here are the drawings for everything. Obviously you can see they all seem to have come out pretty well. Here's the assembly drawing with a bill of materials, some general notes that I just added as if you were actually going to be shipping this and assembling this. So yeah, and then before the conclusion, just to go back through and kind of touch on a couple things I was hoping I would have been able to do that unfortunately I was not able to. If we go back here to this assembly, so unfortunately, like I stated previously, the inside of these has a electromagnet that when you turn that dial there activates, so you can have it not move and just stick to whatever ferrous surface you have. I tried to find online like good examples of how that magnet on the inside worked, but I was not able to find, unfortunately, any documentation that actually covered it. I was hoping to. I thought that would have been interesting to model, but I wasn't able to find any. And then I don't have a personal dial indicator that I could have maybe taken apart and tried to get a peek into. So unfortunately, I just kind of had to skip over that. And also, if you see here on this left picture, we have the Noga, the actual company's name, and the positive and negative there. And I was hoping I could try and find some way to add that decal here onto the faceplate, but I wasn't able to find any way that would look nice and not take away from the project. So if we go to our conclusion here. Obviously, through this project, I learned to better understand and recreate mechanical parts. I think the final product does look pretty similar to the Noga ARM bases that we have at work that I've used. I gained a lot of familiarity with SolidWorks, which was definitely an interesting experience. With the last class I taken not being the engineering technology SolidWorks class, it was actually the engineering department's intro to SolidWorks class. There was a lot of hoops to kind of jump through from such a kind of surface level understanding of how SolidWorks was used to going to a much more in-depth kind of CAD focused instead of engineering focused SolidWorks use. And I got a good amount of practice defining parts in an assembly and actually creating kind of a package, if you will, for a bill of materials for a project like this where you have your assembly and then you actually have the individual parts as well, and you have to take all those drawings together and give them to somebody. If I was going to continue working on this project, future work would be to model the ARM components. I was hoping to get to them, but it was just a little bit out of the scope and time frame of this project. Like I stated previously, I'd love to add the logo and label to the faceplate and the internal components, because it said that there was some kind of system with, I think, maybe copper or some other kind of material and some internal magnets, but I was not able to find anything that really showed it well enough for me to actually be able to model anything properly. And then with my overall class time, it was about 61 hours. I did about 14 of those hours just working on this project. But yeah, thank you and have a great day.